Okay, you just graphed these three polynomials on Desmos, and you needed to identify the location of the zeros, the x-intercepts. So let's go check it out. The first one is graphed in red. So we're looking at this, and it's right up here. We've got x plus 1, x minus 2, x plus 3. It is, notice it is this cubic. It's got that nice kind of comes from down, goes up. This one goes down and back up, and it has that end behavior and those opposite end behavior quadrants. Okay. Now notice the placement of the zeros. There's one right here at -3. There's one right here at -1. And there's another one here at 2. And notice how it is in relation to the equation. Very similar to the factored form of a parabola. Okay, we've got 3 factors here. It's been factored. We've got an x plus 1 factor, and that results in this 0 right here, where the x value is -1. This factor is x minus 2, and it results in this 0 over here at 2. This factor is at x plus 3. Or is x plus 3, and it results in this 0 right here. 3 factors, 3 zeros. Let's take a look at a different graph. Let's look at this one. So let me move it, zoom in a little bit. Okay, let's get a better look at it. Notice, okay, we've got an x minus 2 squared, which means it's really like x minus 2 times x minus 2, and I could actually write that in here, and Desmos will recognize it. So notice the graph is still exactly the same whether I write it x minus 2, x minus 2. It's almost like they're saying there are 2 zeros here at two factors here at x minus 2, which results in 2 zeros here at 2. And notice that there is only 1 0, but it has a slight different look. It looks like that parabola 0, where it's right on the x-axis. Let me go back and change this to a squared. So notice the x minus 2 squared comes down and touches and goes back up. And we have another factor here of x plus 3, which results in this 0 right here at -3. So this one only had 2 zeros. And notice it was really only 2 factors. We've got that extra factor in here that's itself. Okay, so let's go look at the third. So we've got this green one here. Notice it only has 1 0, and it's at 2. And it looks like that nice cubic. Okay, so it's like that cubic. It's only got the 1 0, but just like before, I could technically write that this is x minus 2 times another x minus 2, and the graph doesn't know it's any different. Okay, so there's really like 3 factors of x minus 2 in there. And notice how the look of that 0, it doesn't just pass through like we saw with this one, right? We've got these zeros, they just kind of pass through. Go straight through that intercept. Look at the 0 down here on the cubic. It kind of comes in, it scoots along, and then it goes back up. So it does cross there and it continue across the axis, but it doesn't look like it goes straight through. It does a little scoot. Now look at these ones. This one goes straight through, and that's that x plus 3 factor. This one, which was the double 0 right there, it comes down and it touches and it goes back up. It doesn't pass right through, and it doesn't scoot. It touches. All of these have a role in how we graph, and it has everything to do with that exponent, or how many zeros are actually there, which is what our next note is going to be on. So get your pencil ready and take a note down with me. So this is what we're looking at here, that polynomials have factors. Okay, so notice this. Hang on, we got a technical. Here we go. Okay, so notice we've got, if a polynomial has a factor of x minus a, like, I'm going to do a quick little example, like if I've got a function and it was x minus 2 times x minus 3, right? So this is a factor right here, like x minus a. And then it says that is repeated n times. Okay, so now I'm referring to when that was squared. So this 0 is repeated 2 times. This 0 is only repeated 1 time. This was 2 times. Okay, so then x equals a is a 0. We know that, right? Like A was a 0. But we say it's of order n. Okay, so for example here we've got those, I'm going to go back up. So we took a good note here. I'm going to go back to the previous slide, which those three what we graphed, and I'm going to rewrite them with zeros of order blank. Like this. Okay, so I'm going to move this one over. I'm going to start with the first one. Notice this as three factors. We're looking at this factor. This factor has only repeated once. There's no 2 up here or 3, right? So we've got one factor. It's repeated once. So this has a 0 at x equals -1. It's of order 1. It's an order 1, 0. Okay, so this is new terminology we're using here, order 1. This is a 0 at x equals 2. It's also order 1. It's not repeated more than once. This has a 0 at x equals 3. It is also of order 1. It's only repeated once. Let's look at this one down here. Let me move that back. So let's look at this one, the second one we graphed. Notice here is a 0. It does have a 0 at x equals 2, but it's repeated twice, so we say this is order 2. This one has a 0 at x equals -3. It's only repeated once, so it's in order 1. Are you getting it? Down here, we've got a 0 at x equals 2. It's order 3. It's repeated 3 times. Okay, so that's how we call, each 0 has a particular order. Notice the graphs. Let me go back and have a quick peek at the graphs. They're important. Maybe not. There we go. Okay, so have a look at the graphs. So notice that right there, we're looking at the blue one, which was the middle one. Remember, that was a 0 of order 2. Look at the 2, the order 2. It comes down and touches and goes back up. This was order 1. It just passed right through. Let's look at the one that was order 3. It's the one that came and scooted across. Look at the first one. These are all order 1 zeros, and they all just pass through. So if I create a new function, and it's got x plus 1, and I make it an order 3, and then I multiply this by another factor, like x subtract 4, and I make that an order 1, notice what the result is. So let me zoom out a little bit. So notice that 0 in there. It came down, it was an order 3 0, and it scooted across. This one was an order 1, it passed right through. So the orders play a huge role in how the graph looks. Okay, so let's look at this example, and we will determine an equation. Actually, I think it's a little bit long on time. I'm going to make another video, watch it underneath, and we'll do this one in a different video.